Okay. Let's continue doing some of these examples. This one is, should we say interesting? We'll say interesting. There's a couple of different ways we can go about this one, right? If we look at the toolbox, okay, if we go through this list, again, just like we start every single one of these, could I write everything in terms of sine or cosine? Like, I could. I could call this 1 over cosine squared, just this piece. Is that the best choice for this problem? Probably not, okay? Because if I do that, whoops, if I change this to 1 over cosine squared x, don't write that down, but if I do that, now I have a fraction with a constant in a fraction. Super gross. Not a good idea, right? So as I've said before, even though this is listed as the first tool, that doesn't mean we should do that. Can we do it? Yes. Should we do it? Not. I don't think so. Not in this case. All right? So we're going to say no to this. Manipulate and substitute Pythagorean identities in for squared terms. Do we have squared terms? Certainly do. Okay? Do we have? We've got two squared terms, right? But one of them should send the bells and whistles going off in your head. Because secant and 1, secant squared and the number 1 show up in one of our Pythagorean identities. Okay? So before I go through the rest of this, understand that this is definitely something we want to consider. A squared term with the number 1. Okay? Now, factoring out common terms in the difference of squares, we're not factoring here because we have a fraction. Okay? So we're not factoring. We're not factoring. Okay? Find a common denominator and combine fractions. Emphasis on the s, right? Because if you have two fractions, make them 1. Well, this is one fraction, so we're just going to leave it for now. Okay? So we're not going to do this. Multiply a binomial and a fraction by its conjugate to produce the difference of squares. Now, sorry, when you look at this, is there a binomial in the numerator? Yes, there is. Do I want to multiply by its conjugate? Remember what conjugates are, okay? Conjugates are terms like this, where we have the same thing in the front and the back, and then we multiply them together to get the difference of squares. Well, this is already squared. And as I've said many times before, this is an extremely rarely used tool, so we're not going to go that route. But look at this one. Could we decompose this fraction because of the binomial up top and the single term in the bottom? We call that inverted triangle shape. Could I do that here? I could. I have a binomial in the top and a single denominator. So this is an option. Okay? That's an option. Do I want to do it? This is where you get to choose. Choose your own adventure. Right? One of these two methods is going to get us to the simplified form a little bit quicker. I'm not going to tell you which one it is. Okay? We could look at doing it both ways, but let's do this one. This is where we have our most experience. So let's go there. Right? Our Pythagorean identity is not necessarily this, right? Stay with me. We go into the margin and we write down our Pythagorean identity. Whether it's x or theta or whatever. I guess, why don't we write x, because this problem is written in terms of x. I don't want to confuse you guys. It doesn't matter what we write there, as long as it's the same thing. Okay? So there's our Pythagorean identity. And the tool says manipulate and substitute. So how do we manipulate this? We want it to look like that. So what can I do here in the margin on the side to get a statement that says secant squared x minus 1? Well, I can subtract this 1 over to here. Now when it's over there, this statement says tangent squared x equals secant squared x minus 1. So there's the manipulation. The substitution is to bring that term in its place. So I'm cutting out this from the problem that I'm doing, and I'm putting that in its place. There's the substitution. So this comes out, and in its place I put tangent squared. Now that's a little bit simpler. So there's the usage of the tool. The tool was used to substitute something in for that. Now I'm supposed to simplify. I'm supposed to look at what the result is and say, what do I do with that? Well, there's not much I can simplify. Combining like terms, multiplying, anything like that, no. So if there's no way to make this look simpler right away, I can go back to the toolbox. Okay? Now, when I started this problem, it looked different. Now that it's a kind of a new problem with where we're at now, we can start from scratch and go through all the tools again and say, okay, what about, could I write everything in sine or cosine form? When we started this one, I was like, let's not do that. Because I didn't want to have the 1 over cosine squared minus 1 at the top. That was a problem. Okay? But now, when I look at this, now that might make sense. Now it might make sense to write this as sine squared over cosine squared. So I'm going to do that. Okay? And again, I'll color code this for you so you can see it. The top becomes sine squared x over cosine squared x. And the bottom is still sine squared x. And just like in the opener, we have a fraction sandwich, right? Look at what we did in the opener. I think I might still have it. Oh, I erased it. My bad. Bad foresight, Mr. Jackson. Okay. But the fraction sandwich, come off to the side. Right? When we have a fraction divided by a non-fraction like that, we just take this and multiply it there. So I'm going to take this and multiply it straight into the denominator. So this becomes sine squared x over sine squared x cosine squared x. And because this is a product down here, you're looking at this string of characters with letters and little numbers in the corner, we have to see the trigonometric package as one piece, right? So we have this one piece right here. We have that same piece down here. And that's being multiplied by that, so I can cancel. Which leaves us with, in the top, we have to put a 1 there. On the bottom, we have cosine squared x. And we should at least recognize that when you have 1 over cosine, that means something to us, right? We have that on our sheet, on our trigonometric identities sheet. This is equal to secant squared x. Okay? So, we used the tool, we couldn't simplify, we went back and found another tool, we used that, we simplified. That's pretty simple there when we get to the end. That other method for decomposing the fraction would have been a lot worse.